Welcome to this video, guys. In this video going to learn about the closures, okay, in Node.js. So actually, what is the closure? Closure is a function that remembers the variable variables from its outer scope, okay, even after the outer function has executed. Okay, it's meaning that let's suppose that we have a function inside the function which is called a closure. So outer function is already executed, but the inner function which is there, it will remember the variables which are declared in the outer function, okay, and it will do the action with that one. Okay, so why the closures are useful? Because to data encapsulation we can use the closures. So it will keep some private variables, we can use them directly and maintain the state of the function. And of course we can use in callback functions, timers, API calls, we can use this one. Okay, how the closures works? Of course I already told, it will remember the outer scope variables. And what are the variables it can access means it can access its own variable anyway, and it can access the global variables, of course, and variables from its parent function. That is the main one. Variables from its parent function, that is the main functionality of the closure. It will access the variables from the parent function even parent function is already executed. Okay, even if the outer function is removed from the memory, the inner function still retains the references to its parents variables, okay, and preventing them from being garbage collected. Okay, this is the main thing in closures. Okay, let's see with the example. Here we have outer function called counter. Okay, we have inner function. Okay, the counter is equal to 0. If you see in the first code, this increment that counter, the counter will return. That means the counter is already executed, but the inside the function still remember the variable count, and it will increase the count and will print the results. Okay, and the similar fashion we can use with asynchronous code, that is timers, API calls, database calls, all calls. Okay, in this calls what will happen, asynchronous code will not wait for the complete execution, right? So it will go out. Let's suppose say in this case set timeout, it will execute after delay of 2000 microseconds. Okay, delay is given 2000 microseconds, so it is taking the variable from message and delay, that is outer function variables, which is taking even after the execution of delay message also. This similar fashion will happen with the API calls. Okay, let's suppose that we want to fetch the data from this URL. Okay, so we are giving to this function, but this function is returning what? The callback. Okay, so that means after returning this fetch, the the upper variable one is already executed, but still the inside the one, it will take the URL from it and it will do the process further. And the similar fashion, state management, suppose say we have a counter here, we have an increment and decrement function. This counter each time will increase to 1 0 or -1 -2 based upon the increment decrement operations. These operations will remember the state of this one, I mean the count, and it will do this operations. Okay, so in a real time we will use for the session management, rate limiting, cache systems, API calls, database calls, whatnot. The closures is useful so much. Okay, we have to know about it. Okay, it's enough theory. Let's go with some code. Okay, let me execute the code and show you how it works. Okay, it is simple code. Okay, I have given a counter code only. Okay, in increment I am giving the 1 2 3. This is formal variables for the insert function. Okay, let me execute the code. Okay, I am using the JavaScript debug terminal. I kept the breakpoints so that we can see the flow. See, the first one is increment. Okay, counter. Okay, this is the outer function. See this outer function, this is local. Now this local indicating the outer function counter. Okay, counter, and of course it is a function, so it have its own this, and of course global is available for everyone. This is the local counter. If you have a count with undefined, now count is equal to 0. It is returning means the counter function will be executed, it will be removed from the memory. If you see this one, after clicking this one, you don't see this counter anymore. See, there is no counter now. Okay, now it is returned what? It is returned this function, the closure inside one. Now if you execute this function, see now the local is this function. Okay, of course this function don't have any name, so that's why function n. Okay, n is equal to 1. Okay, see this is the normal function, so it have this. Okay, now this is the interesting one, the closure. the closer, which is the outside one variable. We see the count is equal to 0. Are able to see, right? The count is equal to 0, which is accessing the variable from the outer scope. Even the outer function is already executed. Okay, that is what I stated, right? So now it is increasing. That means we are changing the state of this one, the count. Okay, 0 to 1, and of course I have given one more 1, so 1 plus 1 will get 2. So next iteration we will see now n is equal to 2, and the closer, if you see, it is maintaining the state of 1, which is previously executed, right? So now it will become 1 plus 1. Again I'm changing the state of it, 1 2. Okay, now I'm printing 2 plus, of course, this 2. 2 plus 2 is equal to 4. Okay, see here, whatever the function it is able to access, this is the local variables, n is n, that is the local one, and this is the global one. Of course it can get this, console logs, these are all global variables only. And the count is equal to 2. This one is the closer one, which is from the outside scope of this one. So the closer is able to access these three kinds of variables, that is global, it's local, and the one which is from this parent. Okay, again one more time, you can see I am keeping the state of 2. Okay, now I'm increasing the state to 3, and 3 plus 3 is 6. Okay, this is how the closure works. Okay, thank you for listening, guys. We'll meet in the next video.